developers, and welcome to day 2 of this ROS2 Learning Week 2024. Hello, everybody. I hope that I can see some familiar names today here from the students that were here attending to day 1, but also some new names hopefully are going to join us today. And today we are going to be checking some Python fundamentals, Python basic concepts. So with this, we are going to complete the requirements in order to start actually learning ROS2 next week. Yeah, so yesterday we covered the Linux for Robotics course. Hopefully all of you have been able to complete the course and have all these required Linux basic knowledge. And today we are going to focus on get to know the basic concepts of Python programming. All right. So yeah, again, hello everybody. Welcome to this day 2, and let's get started already. So let me go here to my computer screen to start checking on the chat. Paul Powers is saying, sorry, I missed day 1. Looking forward to seeing you in an hour. Okay. I have missed day 1 also, Habib. Okay, no, don't worry. Even if you miss it day 1, I think you are going to be able to catch up today in day 2. So no worries. So yeah, hello everybody. We have people from China, from Barcelona. So yeah, then probably we have some new people here today. So let me remember that during this whole week, we are going to be doing a daily class of 1 hour from the very fundamentals to getting to know the basic concepts of ROS2. And we are going to finish on Friday with a final project. Yeah. So down here, if you scroll down, you can see the full agenda of this ROS2 Jazzy Learning Week. Day 1, which was yesterday, we covered the basic Linux concepts. Today, which is day 2, we are going to cover essential Python 3 programming skills. On day 3, which is tomorrow, we are going to start getting to know the basic concepts of ROS2. On day 4, we are going to dive into topics, which is one of the most, if not the most important ROS topic. And then on day 5, we are going to practice and put everything that we've learned during the week together into a final project where we are going to, me and some of you are going to get to practice with a real robot. Okay, so this is the agenda for this week. Then today we are in day 2, and down here you can see the course that we are going to be working with today. Yeah, so if you click on this course, I'm going to click here myself. This is going to open the page with the course that we are going to be covering today, Python 3 for Robotics. Yeah. Then in order to access the course, all you have to do is to click on this button here, Open Course. And then this is going to automatically take you to the course page, which is this one that is loading right now here. For you, probably this is going to take you to the Unit 1. Let me move to Unit 1 also myself, because this is going to take you to the if you have not opened this course before, then you are going to be redirected to Unit 1, to the very first unit, okay? So please, all of you, follow these steps that I have just described and open this course, Python 3 for Robotics, so that we can follow it together. Yeah. So let me have a quick look at the chat here. Okay. Also, Christian says that he missed day 1. No worries. Hello from Turkey. Okay. So let me know. Have you already opened the course? Yes. No. Any problem so far? Yes, says Mitesh. So Yuhon, Kailash, Martin. Okay. Lily says, my very first time with ROS 2. I am very excited. Okay. I'm happy that you are excited, like Lily. Today we are not going to be learning yet ROS 2 directly. Okay, we are going to see a bit of ROS 2, but it's not going to be the main focus. But starting from tomorrow, we are going to focus 100% on ROS 2. But we need first to get some foundations before actually getting started with ROS 2. Okay, so it seems that everybody has been able to open the course. Then let me remind very quickly for the new ones, this is how the course page looks. So here at the left side, you are going to find the notebook with all the explanations, instructions, example codes. Basically, all the material that we are going to be following is described here in the notebook that you are going to see in the left. You can maximize all the windows at any time and set up this course screen as you want. Now, in the upper center part of the screen, you are going to have the code editor. Yeah, this is a regular code editor where you can manage your folders, files, create new files, edit code, etc., etc. Now here, also in the center part of the screen, but in the bottom, you have the terminals. These are Linux shells, Linux terminals, where you can type commands, like the ones that we learned yesterday. All right? And then finally, here in the upper right side of the screen, you are going to find the simulator. Yeah, this is a gazebo simulator. In this case, we have the simulation of a robotic arm, but we are going to be changing the robot that we are going to have here. But basically, the purpose of this simulator is that the code that we are going to be creating today, we are going to always apply it to a robot. Yeah, our courses are always practice-based and focused on applying everything that you learn to an actual robot. Yeah, in this case, it is simulated. Now, here we are in the first unit of the course. This is the introduction of the course where some things are explained, like, for instance, why you need to learn Python. Well, Python is the most popular programming language for robots alongside with C++. Yeah, so it is mandatory to have Python programming knowledge if you are aiming or if you want to work with robots and programming robots. Yeah. Also, for instance, Python is the main language for many artificial intelligence libraries. Yeah, such as OpenAI libraries, OpenCV libraries, also for image processing and perception, TensorFlow with deep learning. So many AI tools, AI libraries are based on Python. Yeah, and also another very important point is that Python is the main programming language for robots in the area of education. Yeah, so whenever you want to learn or you want to teach how to program robots, the main language that is used here is Python. Yeah, because it's much more easier than, for instance, let's say C++. So the simplicity of Python allows you to focus only on learning ROS and not have to worry about other things related to the programming language. Okay? Now, so basically here we are describing the importance of Python and why we are teaching this course, this Python for Robotics course, as a foundation for learning ROS 2 in this case. Yeah. However, we are going to skip the rest of this introductory unit because we have some demos and some more other things. But since we have limited time, we have 1 hour for this class, we are going to jump straight to the chapter 2, to the unit 2 of this course, which is basically the start of the actual course. All right? Then in order to change unit, you can click on this arrow here, which says go to the next unit, or you can click here in the unit name, and here you are going to have all the units of the course, and you can select which one you want to go to. In this case, I'm going to go to unit 2, which is titled Python Essentials. All right? Then here you are going to see that the notebook is going to change to Unit 2 Python Essentials. This is the notebook that we are going to be following in a moment. And also you are going to see that the simulation is going to change. Yeah, from the robotic arm to now I think we are going to have a turtlebot simulation, a mobile robot simulation. Okay, so please, everybody, make sure that you have the Python for Robotics course opened and that you are in Unit 2. Okay, I need everybody to be on the same page so that we can start advancing through the course all together. Yeah, and why this is important? Because this class is an interactive class. Okay, so I'm going to be teaching some things here, but I'm going to also be creating code, executing code, and everything that I'm going to be doing and showing today, you can and you have to replicate it on your site. All right? This course is accessible by everybody. You can complete this course 100% totally for free. Okay? So I want you to be advancing and to be completing the course alongside with me. And also, if you have any problem, any question, meanwhile, you can post it, of course, in the chat. And I'm going to be checking the chat in order to try to answer any question that you have, any problem that you might get. So, let me know, please, if all of you are already in Unit 2 of the Python course. Yes, no, still loading. Always we have some people. We have always some people who is late joining and they are a bit lost. So if that's the case, just let me know. Okay, so Mitesh, Habib, Kamran, they seem to be ready to start. Also Christian. Also Lily, loaded Unit 2. Okay, awesome. Then let's get started with the course, okay? So, first of all, I want to clarify again that this course is meant to teach you Python programming basics, okay? This course is not meant to teach you ROS. However, in order to be able to interact with the robots while learning Python, we need to introduce a little bit of ROS, because ROS is going to be in charge of directly communicating with the robot motors, robot sensors, etc. Yeah. So for that, what we are going to do is that through all the course, we are going to be using a Python class, which is named robot control. Okay. Then this class, which is it's a Python class, but it contains ROS. We are not going to directly be reviewing this code because, as I was saying, for this course, I want to focus only on Python, okay? But we are going to be interacting with this Python ROS class in order to be able to also communicate directly with the simulated robot in order to move it, etc. All right? Then, before actually getting started here with the first exercise and introducing data types and variables in Python, let me quickly remind you about our Robotics Developer Masterclass program. Yeah, this program is especially designed to teach you everything you need to know about robotics and ROS so that you are ready to work in robotics in 6 months. Yeah, so if your goal is to, I don't know, maybe switch your career to robotics, or you are starting to learn about robotics and you would like to get a job in a robotics company, the opportunity is now and is here with the Robotics Developer Masterclass. You have here the link, and let me also explain you that with this masterclass, you are going to learn from the very foundations, from the very basics, so you don't need any previous knowledge. You are going to learn from the very, very basic stuff to a much more complex stuff, including autonomous navigation, perception, manipulation, etc., etc. You are going to be working with simulated robots, but also with real robots. Okay, we have set up here in our facilities at Barcelona some remote real robot labs so that you get to practice also with real robots. And yeah, basically that's it. We are going to start a new batch of our masterclass in September. So you have a great chance here to join and get to know everything you need about robotics and ROS in order to land a robotics job in 6 months. And I am saying this also because for this ROS to Learning Week, we have a special discount coupon of 100 euros off per month. Okay? This masterclass program is supposed to be finished in around 6 months. So with this discount coupon, you are going to get 100 euros off each month. So that would make a total of 600 euros off. So yeah, this is for all of you, for all the attendants to the ROS to Learning Week. You have this coupon available in case that you want to join our masterclass program. And yeah, basically that's it. So having introduced all of you to the Robotics Developer Masterclass, let me continue with the class. And we are going to start by the very, very basic stuff, which is data types and variables. And in order to introduce this, we are going to start with an exercise. Okay? Now, here what we are going to do is that we are going to create 2 new Python scripts. Yeah? And for this, we are going to start using some of the commands that we learned yesterday, like cd for going to a specific path in your Linux file system, mkdir to create a new directory, touch to create a new file. Yeah, all these commands, we reviewed them yesterday in the Linux for Robotics course. So let's start. Let's start by executing the first command. Remember that you can copy the command directly here from the notebook and paste it into the terminal. Yeah, this is the fastest way to follow all these commands that are described here in the notebook. Now, second step is to create a new folder named Robot Control here. There we go. After this, you should see how a new folder is created here named Robot Control. Now we are going to go inside the Robot Control folder, and here we are going to create 2 new scripts. First one is named pyscript1.py, and the second one is named Robot Control class.py. Okay? This Python script is the one where we are going to put our ROS code. Okay? Then, in order to paste the code into this file, we can do it very easily from the code editor here. So we can open our robot control class py file like this, and then in the notebook we can just select the code like this. We select the code, and then we copy and paste it into the file. Yeah. So at the end, you should end up with something like this, okay? Now, this is a more complicated code at this point, but don't worry, okay? You don't need to understand this code right now. This is not important, okay? All you need to know is that we are going to be using this code in order to communicate with the robot, okay? And this code already includes ROS, but don't worry, okay? We are going to get to dive into ROS2 in the next days of this week. So for now, just don't worry. Okay. And next, we are going to also copy and paste some code into the pyscript1.py. Okay? It's this code that appears here. So let's also select this code, copy it, and paste it into the pyscript1. There we go. Okay? Now, finally, we can very easily execute a Python script with the Python keyword. Okay, you can use Python, you can also use Python 3. It doesn't matter in this case. So let's execute this pyscript.py with the following command. Python pyscript1. Okay, Then here we can see some messages being printed here into the terminal, yeah? It says robot turtlebot, checking laser, and then here we have our reading, which says 2.5 something meters, yeah? Now, what is happening here? Okay, so several things are happening here. Let's go step by step. Let's have a look at this code. So, at the very first line, we have what we know as an import. Yeah? An import in Python is when you are importing into this program, into this file, some code from another file. Yeah, basically that's it. So in this case, what we are doing is that from this file, robot control class, the one that we have here, we are importing this class, robot control. This class here. Why? Because we want to use some of the code that this class provides, some of the methods that this class provides, okay? If you are completely new to Python, maybe you don't understand some of the things that I am saying now, like module, Python class, Python method, don't worry, okay? All of this, you are going to be able to learn it later on the next unit of the course, okay? But right now I need to introduce these concepts, okay? Then first line, what we are doing is to import this class that we are going to use in order to communicate with our simulated robot, as I already said earlier, okay? Now, here we are creating an instance of this class, yeah? So that I am able to use it. Yeah, in order to be able to use this, I need to import it and I need to instantiate it. Okay, another keyword that we are going to explain later, don't worry. Then here what I am doing is that using this class, which I have stored the instance of this class in this variable, okay, this is a variable, then using this variable, I am calling one of the methods of the class, which is the getLaser method, okay? This getLaser method is one of the methods that if you check all the methods of this class, you are going to find it, for instance, here, okay? And then I am storing the result of what this method is returning. I am storing it in another variable which I am naming A. Okay? Yeah? And then finally, I am printing into the terminal, in this case, I am printing the value of that the variable A contains. Okay? Yeah? So here I have introduced, as I was saying, I have introduced some concepts like Python class, Python method, calling a method, all this kind of stuff. Maybe right now you have no idea of what I am talking about, but don't worry, because we are going to be learning all this much more in detail in next units. Okay? Yeah? Then, yeah, so we have reviewed the import. Here you have some more detailed explanations of all this, in any case, okay? Calling a method of the class, which we are doing here, yeah? And this getLaser method, what does is that it returns the readings of the laser, yeah? So if we have a closer look at this robot, the turtlebot robot, you're going to see that it has a laser mounted here on top of it. Yeah, this is a LiDAR laser. Yeah, and LiDARs basically what do is that it scans the surroundings of the robot like this with laser rays. Yeah, and then if a laser ray finds an obstacle on its way, it's going to return the value of the distance from the laser to the obstacle detected by the laser ray. Yeah? In this case, for instance, the laser beams which are in the front side of the robot are going to collide against this wall. Yeah? And then with this, we are going to be able to detect the distance of this wall with respect to the robot. Okay? And then as you can see here, when we are calling this getLaser method, we are sending what is known as a parameter. Yeah? In this case, this parameter is a number, and this number corresponds to the number of the laser beam that we want to get the reading from. Yeah? For instance, if we call this method with the number 0, then we would be getting the reading from the laser beams here. In this case, we are calling the method with the number 360, as you can see. Therefore, what we are doing is to get the reading of the laser beam which is right in front of the robot. Yeah? This is what the returned value is 2.5 meters. Yeah? Because this specific laser beam is detecting this wall at a distance of 2.5 meters. Okay? Here we are mixing a bit of Python with a bit of ROS, but okay, this is so far to get you an idea of how we are interacting in this case with the robot. Okay? So basically what this class provides is a series of methods in order to interact with the robot. For instance, we have this method which is to get a specific laser beam reading. We have some other methods which are to move the robot forward, to stop the robot, to turn the robot. Yeah? So this class provides a series of methods that during the course we are going to be calling in order to interact with our robot. Okay? This is why I am introducing all these concepts right here. Okay? Yeah, and getting the output of the method. So in this case, we are getting the output of this method and storing it into a variable named a, which later we are printing using a print function. Yeah? Okay? Yeah? So far so good. Any questions regarding this introductory part? Let me have a look at the chat. Franco Macen is asking, little question about that. I suppose you refer to the masterclass. Those jobs can be remote for any part of the world, e.g., for example, Argentina? Yes, of course. That depends on the company. There are companies that are going to offer remote job positions, or there are going to be on site. Yeah. Rocky is asking, I missed day 1 of the course. Is there any way I can watch it later? Yes, Rocky, you can watch it in our YouTube channel. Okay, in our YouTube channel, we are going to publish all the different sessions of each day. Umami is asking, how would we know that about the parameter for the laser without a specs doc? It's not possible. That's a very good question, Umami. So Umami is asking, if I understand correctly the question, Umami is asking, how do I know that that for calling this method I need to provide a parameter which is an integer? How would I know that without a documentation? And the answer is you cannot, Umami. So whenever you want to call a method, you need to check for either the documentation provided by whoever has created this class. Yeah. So this is like an API. Yeah. So whoever creates an API for a robot, which would be this, he needs to provide documentation of which methods you can call and how to call them. Okay. In the case that this documentation is not there, then the other alternative is to directly check the source code. Yeah. So checking the source code, you can see that there is a method named getLaser, and that this method is expecting an argument. Okay, a parameter here. But ideally, whoever creates the API is going to provide documentation of how to call the methods. Okay, that is a very good question, Umami. Jonathan is asking, so if my robot had his own LiDAR, I had to adapt to the LiDAR documentation. Exactly, Jonathan. So in this case, this LiDAR, for instance, in this case, this LiDAR has a range of 180 degrees in front of the robot, okay? But depending on the LiDAR model, this is going to change, okay? For instance, there might be some LiDARs that cover 360 degrees of the robot, yeah? In our case, this LiDAR is not able to detect any information which is behind the robot, yeah? Because it only covers 180 degrees in front of the robot, but all the part which is behind the robot, this LiDAR doesn't cover it. But there are other LiDARs that cover 360 degrees, okay? And for another LiDAR, checking the laser beam 360 might not correspond to the front of the robot, okay? This depends on the LiDAR configuration, etc. So you always need to check for the documentation, of course. Okay, then let's continue. So variables. Okay, then in Python, we can declare a variable just like this, okay? It seems like magic, but just by writing the variable name here, we are declaring a new variable, yeah? And then somebody, you might ask, okay, Alberto, but what data type is this variable? It doesn't matter. Basically, this variable is going to get the data type that is received from the output of this method. Yeah? So this variable is going to adapt to the data type which is returned by this. Okay? This is a very significant difference with respect to C++, where you have to specify the data type beforehand. Okay? In Python, this is not required. It's much more simple. Okay? For instance, let's do an example. Here we are using we are going to use the command line Python interpreter by typing here Python 3. If we type Python 3 here in the terminal like this, we are going to be able to use the command line Python interpreter, okay? And for instance, here we can write some Python code like a equals 5. Sorry, I need to change here to the Spanish. There we go. A equals 5. Okay? So here I am declaring a new variable named a, and I am assigning the number 5 to this variable. Okay? But I can, for instance, I can already print the value of this variable, and the value is going to be 5. But I can also change I can change whenever I want the value of a variable. For instance, now I want to change the value of a to 6. And then now if I print again the value, it's going to be updated to 6. But not only this, but I can also change the data type. For instance, now instead of a number, I want my variable a to be an integer. To be a string, yeah? So this is now a string. Yeah? And then if I print a, now this is a string. Okay? So you can change the value of the variables, and you can also change the data type of the variables. There are many different data types in Python, but the most common ones, the ones that we are going to be checking, are numbers, strings, lists, tuples, and dictionaries, okay? These we are going to do it in a moment. But now we have a quick exercise. By the way, you can exit whenever you want the Python interpreter like this. Exit, and that's it, okay? So here we have a quick exercise that we are going to do to practice. So inside the Catkin Workspace SRC robot control folder, yeah, so inside this folder, create a new Python script named variables.py. Okay, so we can right-click then here in the folder, new file, and variables.py. There we go. Then it says, inside this script, add the necessary code that does the following. Okay, first you will call the method getLaser with any number and store its response into a variable named laser1. Second, you will print this value in order to see what you get. Then you will call the getLaser method again with a different number, and you will store its response in another variable named laser2. Then again, you will print this value in order to see what you get now. Finally, you will call the getLaser method one last time with a different number. Now you will store its response in the same variable laser2. And you will print again the value of this laser2 variable to see what you get now, okay? So in this case, I'm going to go straight to the solution because this is something very basic. And we are going to copy and paste the solution here, yeah? So here we are exactly doing this, yeah? So first of all, if we want to use the getLaser method, we need to import the robot control class, and we need to create an instance of this robot control class, right? And then here I am calling the getLaser method with one number and storing the returned value into a variable named laser1, and then I am printing this, the value of this laser1 variable. Second, I am calling the getLaser method with a different parameter and storing the returned value in another variable named laser2, and then I am printing this laser2. And finally, I am calling again the getLaser method with a different number and storing the returned value in the laser2 variable. And then I am printing this laser2 variable. All right? So if I execute this, what am I going to get? Let's see. Python variables.py. Okay, so we get, for the first getLaser method call, we got an infinite value. Infinite means that the laser beam is not detecting any obstacle, yeah, which makes sense because the laser beam 0, if you remember this image, corresponds to the right side of the robot, yeah, which in our case, the right side of the robot doesn't have any obstacle, right? Then the returned value is infinite. Now, in the second call to the method, we send 360, which corresponds to the front of the robot, and in this case, we are detecting the wall, so the returned value is 2.5 meters. And finally, we are changing the value of the laser2 variable with the returned value from calling the getLaser method with the parameter 719, which corresponds to the left side of the robot. And in the left side, again, we don't have any obstacle, so the returned value is infinite. Okay? Yeah? And now, let me go also fast over these data types. So there are many data types in Python, but the most common ones are these ones. Numbers, which can be integers, can be floats, yeah, for instance. We have strings also, yeah, which are basically a series of characters together. And we can also, for instance, concatenate strings like this. Okay, for instance, let me open the Python interpreter to do some of these tests. For instance, S1 is this and S2 is a string. Yeah. So you can now concatenate the two strings like this. And then if we print S3, we have the sum of 2, okay? And also, as it was shown here, we can print a specific character of the string. For instance, if I print S3 1, okay? If here I print S3 1, what character am I going to get? Can somebody tell me in the chat? What character of the string, what letter of the string am I going to get if I print this? Does somebody know? H, second, H letter. Okay, let's see. Very well, very well. Okay, so I see that you are following. Okay, let's keep moving. Then we have also lists, yeah? A list, as you can see, is a series of elements, like you can see here, yeah? So here we are declaring this list with a series of elements, yeah? So a Python list is an ordered sequence of items where all the items of the list do not need to be of the same type. As you can see, we have integers, we have strings here, yeah? Then we can print the whole list. Okay. Yeah, so we can print the whole list like this. Yeah? Or we can print a specific element of the list like this. Print, print L, for instance, 2. And this is going to print the second element of the list, right? Which is the number 3. Why? Because 0, the first element is the 0, 1, and 2. Yeah? Or we can print, for instance, something like this, which means from the 0 position, from the 0 element, 0 item, which is this one, to the third element of the list, print everything. So 1, 2, 3. Okay? You have more exercises here. You can check them if you want. Then we have the tuples, which basically are a series of values separated by commas, which are enclosed with parentheses. Yeah? And the particularity of tuples is that they cannot be updated. They are read-only. Yeah? So a list, for instance, can be updated, but a tuple cannot be updated. They are read-only. Yeah, and finally, we have the dictionaries, which are similar to lists, but in this case, each value is associated with a key. Okay? For instance, let me declare this dictionary here. Yeah, so this dictionary is named dict, and you can see the keys here. This key is John, and the value of this key is 25. We have a second key with the value 22, another key with the value 31, yeah? So dictionaries have pairs of key value, okay? Then, for instance, we can print a specific value of the dictionary by providing the key. In this case, if we print the key John of our dictionary dict, we are going to get the value 25, right? Also, dictionaries can be updated, yeah? Okay. Now, here we have another exercise. So let me exit. Well, so far so good. Are we following it? Are we following so far the introduction to variables, to data types? Yeah? Can I print a letter in a string inside the list. Okay. So Abdullah is asking, in a list, we had a list here, right? For instance, so we have this list, Python. So we have this list, right? So he's asking, can I print one of the letters inside and a string inside the list, right? Okay, so let's try this. Then, first of all, we will need to access the value, for instance, print L, and here we have the element 0, 1, 2, 3, for instance, right? This contains the string this, right? So, can we do something like this? Then how would we do this? 3. Try like this. 0. Okay. So does this answer your question, Abdullah? I think this is what you were asking, right? Yes, thanks. Okay, awesome. Okay, then I can see everybody saying yes, yes, yes. So let's continue. Let's continue. Okay, then down here we have an exercise, right? So here it says, create a new Python script named lists.py. Okay, so let's create a new Python script named lists.py. Okay, there you go. Inside this script, add the necessary code that does the following. First, you will call the getLaserFull method and will store its response in a Python list. Then you will print the positions 0, 360, and 719 from the full list of readings. Okay? Again, let's have a quick look at the solution here. And we are going to quickly review it because these are all very simple exercises. Okay? Then again, we need to import our class and instantiate our class. And then we call the getLaserFull method. Okay? Here you have a brief explanation of this getLaserFull. Yeah? As the name itself says, this method will allow you to get all the data from all the laser beams of the robot. Yeah? So remember, with the getLaser, we get the data from only one of the laser beams. From getLaserFull, we get the data of all the laser beams, which in total are 790 laser beams. Then, as I've said before, this is a total of 720 different readings. So, when called, this method will return a list containing all the 720 different readings from the laser beams. Yeah? Then, we are calling this getLaserFull, and we are storing this into a variable s. So this variable L is going to become a list, right? Therefore, we can access any of the readings by accessing one of the items of this list, like this, okay? So let's execute this code. Here, Python lists.py. Yeah? Okay, here we have another exercise. Create a new Python script named dictionaries.py. Inside this script, add the necessary code that does the following. First, you will call the getLaserFull method and will store its response in a Python list. Then you will create a dictionary that will contain the position in the list and its corresponding value as k-value pairs. Check the example below. Position 1, 5. Position 52, 32. Position. You will do this for the following positions in the list. 0, 100, 200, 300, 400, 500, 600, and 719. Finally, you will print the resulting dictionary. Okay? So again, we have here the solution. So let's create another Python script here named dictionaries.py. And let me copy paste directly the solution. Okay, so we have something like this. We are importing and instantiating our method. We call the getLaserFull, which we store in a list. And then we create a dict with all the keys, position 0, position 100, position 200, etc. And for each key, I store the corresponding laser beam from the corresponding item in the list. Yeah. So for the position 0, it's the item 0 in the list. For position 100 is the item 100 in the list, and so on. And finally, we print the dictionary. Okay? So this is going to return something like this. Okay? And then here at the end we have some input-output methods. Yeah. So we have already been checking the print method, which basically allows you to print something into the screen. Okay. There are different formats. I'm going to skip this. You can check it later. And we have also input methods, which is in order to get some input from the user. Okay. For instance, let's try this example code. Let me create here a file named input.py. Something like this, and then Python input.py. Yeah. So here, what do we have? We have the input method, where we specify something. In this case, this is a question. What's your name? And then we are going to get the returned value of this method into a variable named name. And then we are going to print this variable here with a print statement saying, nice to meet you, and the name captured by the input method. Yeah. So if we execute this, we see here the question, what's your name? So I'm going to answer Alberto. Then whenever I press enter, this is going to be stored into the name variable, which later is going to be printed here, right? So let me execute this. And then the output is nice to meet you, Alberto. Yeah? So this is a method that Python provides in order to capture data from the user. Okay? Here you have some other examples, etc. I don't want to get too deep into this because you can check it by yourself later with more time, okay? Here you have some exercises to test input, okay? And finally, I want to end here with the operators, which is the last part of this unit. So we have several operators in Python. Basically, we can divide them in arithmetic operators, assignment operators, comparison operators, and logical operators. Yeah? The arithmetic operators are the, for instance, equal. Yeah? Which basically assigns one operator. We have the plus equal, which is to add something and assign. We have some examples here, which actually, let's see them. Okay, so let's start with the let's start with the arithmetic operators, yeah, which is the addition, subtraction, multiplication, division, modulus. Very, very, very simple. So, for instance, A equals 5 and B equals 2, right? So A plus B is going to be what? 7, right? A minus B is going to be what? 3. And so on. Yeah, typical arithmetic operators. Then we have the assignment operators, right? For instance, A equals 5. But what if I do now A plus I equal 1. And then I print again A. Yeah? So basically what this does is to add 1 to the previous value of the variable, as you can see. Yeah? So initially this was A, so with the plus equal, I add 1 directly to that variable. Yeah? Same goes for the A minus equal 1. Yeah? So now A is again 5. Okay? And for instance, I can do now also A multiplication equals 2, for instance. So now A is going to be 10. I am multiplying the value of A by 2. Okay? So assignment operators, comparison operators. Okay? So now let me remind we have okay, let's do again A equals 5 and B equals 6. Yeah? So for instance, if A equals B, sorry, what am I doing here? Ah, yeah. Okay. Yeah, so here we are doing, okay. No worries. Let's do something, let's do a simple code here so that we can test it everything at the same time, because it's going to be much easier. So let me create here a Python file, test comparison.py. Okay. And then here we are going to see all the comparison operators. Yeah. So A equals 5, B equals 6. So let me execute this Python test comparison. Yeah. So in this case, we have that A equals B is false. So this print statement is not printed. We have that A is bigger than B is also false. So this statement is not printed. We have that A is lower than B. This is actually true, right? A is smaller, is lower than B. So A is less than B should be printed. And here we have it. A is less than B, right? Then we have A is higher or equal to B. This is false. And A is lower or equal to B. This is true. So this is going to also be printed. A is less than or equal to B. Yeah? Now, for instance, if I change this into this, 6 and 6, which ones are going to be printed? Well, in this case, the first one is going to be printed, and also the last one. No, the last one is going to be printed, and also this one is going to be printed, right? So let's try this. Okay, so in fact, we have the first print statement and the 2 last print statements being printed. Yeah? Okay. And yes, and finally we have here how to add comments in Python, which is just using the asterisk. Yeah, so you can add a Python comment whenever you want in the code by using the asterisk like this. This is a comment. Yeah, very important to use comments in your code in order to clarify what everything is doing. Okay. For instance, if we check this class, you can see that there are almost no comments, okay? And this is a very bad practice, okay? So ideally, we should have comments here, for instance. A comment in this method which says, this method returns an specific laser beam reading. Yeah? Very important to use comments in order to clarify what your programs are doing to some external developer who is checking your programs, okay? How can I get these variables in real time using the laser and thanks? I'm not sure I understand your question, Yasin. How can I get these variables? What variables you mean? In real time using the laser? I'm not sure I understand your question. Okay, so yeah, with this we would close unit 1 and we would be ready to move to unit 2, which is a super important unit, okay? We have, so far, questions, comments, so far? Any doubts, anything that you would like to ask? Now it's the moment. Everything is clear so far? All clear, says Paul. Okay. Good. For me, all clear. Excellent. Okay, then let's continue. Okay, we have a few minutes, okay? But I'm going to try to do at least the first part of this unit, okay? And then I will leave the rest for you to complete, okay? Then, okay, conditional statements. So, life is all about making decisions, isn't it? So in programming, actually, this is very much the same, okay? So you always have to make decisions, and usually these decisions are going to be based on something, okay? Then in programming, one of the most essential things that you need to know are conditional statements, okay? So let's imagine the following real-life situation. If there is a wall in front of the robot closer than 1 meter, I will stop the robot so that the robot doesn't crash against the wall. Otherwise, I will keep moving my robot forward. In any case, I will print the reading of the laser. Then this logic sentence can be displayed in a block diagram like the following. So my question is going to be, my condition is going to be, is there a wall less than 1 meter or closer than 1 meter in front of the robot? If the answer is yes, then I want to stop the robot to avoid my robot crashing against the wall because it is already too close. If the answer is no, then I'm going to keep moving my robot. And in any of the two scenarios, I want to print the value of the laser, yeah? So how would we program this? It would be something like this, yeah? If the wall is close, stop the robot. Else, which means if this condition is not met, so if the wall is not close, else keep moving. And in both cases, print the reading. Okay? Then here we can already see something very important in Python, which are the blocks and indentations. Yeah? So you can see that inside the condition, we have some statements. But it is very important, it is mandatory, that the statements have an indentation. They are indented with respect to the condition. Okay? So these indented blocks of code are executed only if the condition is evaluated as true. Yeah? So if this condition is evaluated as true, the indented statements here, everybody understands the concept of indentation? Yes, no? Does somebody don't understand what indentation means? Is this clear? This is very important, okay? In Python, indentation is super important. Indentation is Python is like using these parentheses. I don't know how is the exact name. Yes, Paul Powers. It's not exactly the same, but that is the idea. Yes, curly brackets, that's it, yeah. Okay, so I see that it is clear, okay. Okay, perfect. Then, this is very important, okay, because if these statements are not indented, then they are no longer a statement, they are something else, okay? Okay. Okay, here you have some examples with some stupid things. Okay. Then I want to move straight to this exercise. Okay. So, okay, yeah. Before that, let me introduce the elif. So you can put as many conditions as you want. Yeah. For instance, if condition 1. elif condition 2, elif condition n, and else. Okay, so you can use these conditionals as many times as you want, as you can see here. Okay, and how does this work? If the condition 1 is true, the statements of the block 1 will be executed. Yeah, so if this condition evaluates to true, this statement is going to be executed. If the condition 2 is evaluated to true, this one is also going to be executed. Yeah? If this condition is evaluated to true, this is also going to be executed, and so on. Okay? And if none of these ones are evaluated as true, then the else condition is going to be executed. Okay? In any case, at this point, I want to do the following exercise, yeah? So, inside the robot control folder, create a new Python script named test_if. Okay, so I'm going to create a new Python script here named test_if.py. Then, inside this script, create a program that reproduces the flowchart showed above. Which one? This one here. Yeah? So we want to turn this flowchart, apply it to our robot, to our scenario, and convert it into a Python program here. Yeah? This is the goal of this exercise number 3.1. Okay? Then, for this, we are going to use two new methods. The move straight, which this method allows you to move the robot in a straight line, and then the stop robot, which allows you to stop the robot from moving. Then, with all the information that we have, we are going to convert this flowchart into a Python program. Then, let's have a look at the solution, okay? And then we are going to explain it. So let me copy the solution here. And here we have things that we have been practicing so far, yeah? So we are importing, again, our robot control class. We create an instance of the class. And then here we are getting the laser reading which corresponds to the front of the robot. Yeah? Because this one is going to allow us to detect the wall. Yeah? And remember that the flowchart says, is there a wall less than 1 meter in front of the robot? So for this, we need to evaluate the laser reading in front of the robot. Then this value, we are going to store it in the variable a. Then we check if the value of a is lower than 1, we call the stop robot method. Else, so if the value of A is not lower than 1, then I'm going to keep moving the robot straight. And in any case, I'm going to print the value of A. Okay? See that if I want something to be executed only if a certain condition is met, I apply indentation, as you can see here and here. If I want something to be executed anyways, in any case, I don't apply indentation. Okay? So what is going to happen if I execute this? Let's see. Python test if. Okay, so my robot starts moving forward, but it doesn't stop, and it actually crashes against the wall. Okay? So this is actually not the behavior that we were expecting, right? Because we would like that if the robot is closer than 1 meter to the wall, it stops. But this is not happening with our program. Does somebody know why? Why the robot is not stopping? Does somebody know? One measurement, says Jan Dostoshny. Just one measurement, exactly. So our program has one problem, and it is that we are getting the value of the laser only here, right? Only one time here. While the robot is moving, we are not updating the value of A, right? Then it's basically impossible that the robot is going to know when it gets closer to 1 meter, because we are not updating the value of A. We are not updating the laser reading. Yeah? So how can we fix this problem? Well, for this, we need to introduce another concept, the concept of loops. Yeah? What does this mean? This means that I'm going to evaluate the condition. Yeah? If the answer is no, I'm going to go back and evaluate again the condition. Yeah? And whenever this condition is met, then I'm going to exit the loop in order to stop the robot. So this is going to apply to something like this. While the wall is not closer than 1 meter, keep moving. Then, otherwise, if at some moment this condition is not evaluated to true, then I'm going to exit this loop and stop the robot. Okay? Yeah? So for instance, let me show you the solution, okay, very quickly, because I need to stop the class already, but I want to show you how this fixes the problem. So let me actually restart the simulation here. And let me create very quickly here a test while.py. Okay. So this is how the updated code would look like. Yeah. So we have our class, and then we start by getting the value of the laser. Okay. Then we create a loop here. While the value of A is higher than 1, I'm going to move the robot straight. But inside my loop, I'm going to update the value of A. Okay? So I'm not going to get only one reading, but I'm going to update the value of A inside my loop. Okay? And I'm going to be printing also this value. Then, whenever this is not true, so whenever A is lower than 1, then I'm going to exit my loop and I'm going to stop the robot. Okay? And then if I execute this, Let's wait until the simulation reloads. We need to update the variable with a new value. Exactly. We can create a while loop and then put the measurement variable in a loop so that we will get the new reading. Exactly. Okay. So I see that you already have some experience with Python. Okay. Yeah. Okay. So yeah, let's wait some seconds until the simulation reloads, and then I'm going to stop the class here. Okay, because we don't have more time. I am already passing 50 minutes from the time, 1 hour time. Then, please complete the course on your own, okay? There are many things here that I have skipped, even here. You have different loops. Like, for instance, you can use the for loop, yeah, which is different from the while loop. You have the interruption of loop iteration. So there are many more things here that you can learn related to loops and conditions. Yeah, conditional statements and loops. And you have many more important units here that we are not going to have time to cover, like Python methods. Super, super important. Python classes and object-oriented programming, okay? So let me remind you that this course is completely free, okay? So you can finish it on your own, yeah? And if you don't have all this knowledge, if you don't have clear how to work with Python methods, how to work with Python classes, what is object-oriented programming, please take the time before tomorrow's class in order to complete the rest of the course, okay? Yeah? Okay, then here we have the simulation loaded. Then let me execute my updated code. Python test while. And then here we can see the robot keeps moving and we are updating the value. And whenever the value gets lower than 1 meter, which is here, the robot has actually stopped and doesn't crash against the wall. Okay? Yeah? So is it clear? Yeah? Thank you, thank you. Will be any classes like this one for C++? No, Abdullah, no. So tomorrow, which is going to be the next class, we are going to already start with ROS2, okay? So we have done Linux and Python to provide the foundations, and then tomorrow we are going to start with ROS2. Next class is going to be here, Yuhon Ling is passing the date, okay? So please, again, this course is completely free, so if you have time today and tomorrow before the next class, take your time to complete all the units of this course, okay? Because they are super important and they are going to provide you the foundations that you need in order to properly learn ROS2, okay? So, yeah, let me then leave it here. Thanks to all of you for being here with me in today's class. I hope to see you all again tomorrow in day 3 of this ROS2 Learning Week. We are going to get started with ROS2, so it's going to be a great class tomorrow. And yeah, see you all tomorrow. And remember, keep pushing your robotics learning. Bye-bye.